Hey guys, and welcome back to another Tenfold live show. My name is Philippa and I'm here to bring you the first half of this live show that is focused mainly on matric mathematics. It's proudly brought to you by Liberty. We're so grateful to have you guys here. We're having such a great time this week with your questions. We love hearing from you guys, so don't forget to send in through your videos. We'd love to hear from you on calculus. We're covering calculus for the rest of this week and next week. But also don't forget, guys, we're going to be covering analytical geometry in like 2 weeks. So if you send through those videos, it would be really helpful for us. We'd love to get onto your questions for analytical geometry, guys. Remember that this show is focused on matric mathematics, but if you feel like you need a little bit of a bump, even from grade 10, we have a fantastic app, guys. It's called Tenfold Education. It's available on both Android and iOS stores, so download that, guys. We've compiled some fantastic videos. We've done lessons, examples, concept videos, even videos that help you show what kind of careers you can go into with the maths that we're dealing with. Otherwise, don't forget to catch the show that we're doing, this live show. It's from Monday to Thursday from 5 to 6 p.m. Also, we have a package from 4 to 5 that helps you orientate yourself in the subject that we're doing. So tune in for that, guys. It's some really great content. For now, we're going to go into an introduction video just to help you get your minds into that calculus phase. So let's check out that intro video.
Calculus is a powerful and magical mathematical tool that allows us to make predictions of future outcomes and reconstruct the past. In order to be successful at differential calculus, you will need to understand the concepts of limits, differentiation by first principles, differentiation using rules, equations of tangents to graphs, cubic functions, optimization, and rates of change. Differential calculus is 35 plus minus 3 marks in the final exam, which is about 24% of Maths Paper 1.
Alrighty guys, so that is just one example of the kind of video that you can expect to see on our Tenfold Education app. So if you like what you see, download the app, guys. It's really great. It's got 10 to matric content. So if you feel like you need an extra bump, have at it. Also notice, guys, differential calculus is a quarter of your paper 1. That's a lot of marks. So yeah, you really should tune in, check out our questions, send more questions. We love helping you. For now, I'm going to take the first live question. It's from Kamogelo. Let's see what he needs some help with.
Hi Tenfold, my name is Gabo. Please assist me with this question.
Okay, I love this question because for me personally, calculus graphs, not my favorite. I really don't love calculus graphs. So this is actually really good practice, guys. It's just testing your ability to recognize functions, recognize the possible shapes, and identify what the information they're giving to you actually means. So let's jump right into it. It says, sketch a possible graph of y equals f of x, which is given to us by ax cubed plus bx plus cx plus d. Okay, so we have a whole bunch of variables that we haven't been given, guys. They've intentionally not given us those variables. They're basically looking to see that this is a cubic. They want you to know what a cubic looks like, how to draw it, regardless of the variables that influence that cubic function, guys. They want to test that you know the basic shape. Okay, so we are further given that the second derivative of x is negative for when x is positive. Okay, that's important. Lastly, they tell us that the graph has a point of inflection at the point 0, 1, when x equals 0 and y equals 1. Okay, so first thing that should scream at you is because we have a power 3, we have a cubic function, which means it's going to take this shape or this shape. Now, because we've looked at this here, guys, note the a value determines the shape of this. Because a is positive, it means that the function is going to take this shape, not this one. Wow, I'm actually talking such rubbish, guys. It is going to take this shape right here because a is positive. Okay, Secondly, what you need to notice, because they've given the second derivative to us, guys, that should scream things to you. The moment you see second derivative, you're looking at concavity of the original function. So, if the second derivative is positive, it means that the original function is concave up, which is what looks like over here, that smiley face there. If the second derivative is negative or less than 0, it means that the original function that you've derived twice is concave down. Okay, so guys, remember, when you get calculus functions, the thing you should focus on first is the original function, what shape you're going to get. Then contemplate the first derivative. First derivative dictates where the original function is increasing or decreasing. If you go one step further, differentiate again, second derivative dictates concavity. If it's a smiley face, concave up. If it's a sad face, concave down. Okay, so let's look at what we're further given here. It says, okay, so now we've got this instance here. We've got the second derivative being less than 0. So we've got this instance here, which means that it's concave down. But, guys, we're given this very important interval here. When x is positive, the original function is concave down. Okay, so if we start trying to interpret this graph, before I even try to interpret it, I'm going to make a little note over here. X is positive in this interval, which means that the concave down part of the cubic is in that area. Okay, can be down here, can be over there. We just know that from here is where the cubic is concave. Wow, I'm talking rubbish. Concave down. Sure, I'm on point today, guys. Okay, concave down, where x is positive here. Okay, but they make a very important note here. The point of inflection, guys, is basically where the graph changes from concave up to concave down or vice versa. Okay, so that point of inflection is very important. 0, 1. Okay, so let's draw a graph here. Obviously, you guys will be given axes. I'm going to freehand it here. 0, 1. Okay, where x is 0 is along the y-axis. Let's make that point 1. We know that the graph is going to cut there. We also know that that is where the point of inflection is. Okay, so now we incorporate everything. We know it's going to have this shape. We know that this concave down part is going to happen on the positive x side. So we know that concave down is going to happen from there. And then because we know it's a cubic, we need to fill in this second concave up section. Okay, so we draw it like that. Okay, so let's rerun through what we've been given. When you've been given a cubic, guys, because it's to the power of 3, we know that it's a cubic function. We also know that the value of a, if it's positive, we know that the shape is going to do this. If it's negative, we know that the shape is going to do that. Okay, so that's the first important thing you focus on with a cubic. Second thing, guys, if you differentiate first, the first derivative is going to dictate, if you have the first derivative that's positive, it means that the original graph is increasing. If the first derivative is negative, it means that the original graph, the one that you derived to get to the first derivative, is decreasing. Okay, so those should be two things that scream at you. The next thing, guys, when you differentiate for a second time, that's when you start looking at concavity. So when you have a second derivative, if that second derivative is negative, it means that it's concave down. It's a sad face. It's got a negative life. If it's positive, that second derivative, it means it's a smiley face. It's concave up. Okay, so this question was important, guys, because it said give a possible graph. This isn't necessarily the only graph that could be given by that cubic equation. But because we're not given any of these variables, A, B, or C, we don't know the exact shape of that graph. Okay. So hopefully this has helped you with your cubic functions, guys. I really love doing this question because it actually helped me revise my cubics. I don't love calculus graphs, but I love helping you guys. So it's really great to know that I can help you and try and transmit my maths knowledge to you guys. For now, we're going to jump into an ad break, and then I'm going to be back with the second question that I'm doing for the first part of the show. So stay tuned.